So we've talked about mean, median, and mode. We've talked about variability and standard deviation. Now we are going to do an overview of the terms that your textbook used in plotting your results about skewed distributions. Okay. So in normal distribution, what we expect to see is, let's return to back to the example of the test. Okay. So I gave a test and the results are anywhere from 0 to 100. In a normal distribution, what I would expect to see is most students are going to score, say my orange is my test results. Most people are going to be scoring around the midpoint. Actually, in schools, it's usually closer to like the 70% mark. That's why we say C is average. But what we're going to see is our scores here, and then maybe a few people down here failing, a few people up here getting high 90s, 100%. Okay, so if we're stacking our results this way, in a normal distribution, you cannot hardly see my orange at all the way the webcam is. Let me see if pink will work better. In a normal distribution, what you would expect to see is what we call a bell curve, right? We're going to come up and over and down, and it's going to be pretty even. Art is not my strong suit. Now, what happens when you have a skewed result pattern, when you have a skewed distribution? Let's say my test average was over here at 70%. Okay, let's say this is my average right here, the green, my mean. Let's say in one class, there were some very small scores down here that brought down the average. Somebody got a 5%, somebody got maybe a couple people got a 10%. There's a couple scores down there. But other than that, so those brought down the mean, right? Because they're very, very low. But other than that, the majority of my scores were up here in the 70s and the 60s, okay? So the majority of my scores are over here clustered pretty well around my mean, except I have these little tiny ones down here that brought my mean down. And then, of course, I still have my students who made A's and all that. So what you would see in this is this down here is pretty low, and then it goes up. We call this a skewed distribution. You only have a few on one side, you have a lot on one side, and it's making it look lopsided. Now, the part of this that gets counterintuitive is the tail that has the fewer numbers is where we take the direction of the skew. So, in this example, if we have one that looks like this, we would consider this a left skewed. The flat, short, narrow side that's not going up is on the left. That is a left skew. We also call that negatively skewed. If we have one where there's a lot of low scores, but then maybe a couple people got 100% over here, this would be a right skewed or skewed to the right, also called positively skewed. And I'm hoping that the way the screen mirrors doesn't throw that off. But because I'm right-handed, this is my right-hand side. So the portion that has the shorter side is the direction of the skew. So right skewed, left skewed, left skewed. That can be an important piece of information to have if you plot your results in your statistical software. It can give you a great at-a-glance look to see if there's a problem with your distribution or if it's normal.